All right, so on page 3, we are getting into our focus is how can you predict which fractions will have decimals that terminate and which will have decimals that repeat. So back to what we talked about on the previous page. Okay, we should be on page 3 now, or the first page of the second stable part. Is that for terminating decimals? I'll try to write this as small as I can. Again, terminating decimals slash fractions. Okay, those denominators. Those denominators can go evenly into base 10 numbers. 10, 100, 1,000, 10,000, 100,000, etc. In the non-repeating, non-terminating. So again, the top one was terminating decimals, repeating decimals. They can go into, the terminating decimals can go evenly into the base 10 numbers. The the repeating decimals. Sorry about that. Do not go evenly into the base 10 numbers. All right, I know this thing moves. Let me move it back. Come on. Move back. There we go. And we'll just lock this guy in place. Thought I did that already, but I guess I didn't. All right, so it says Jared tried to scale up the following fractions so that the denominator would be a power of 10. The denominators could be, and that's 10, 100, 1,000, and then so on. It could be 10,000, 100,000. So it says finish Jared's work. The scale factor must be a whole number. So if you look at the first one, we'll do that one together. All right, so they're going 1/2 into 100. So to go from 2 to 100, you can see here we multiplied by 50. So again, to keep a fraction equivalent, whatever we do to the denominator, you have to do to the numerator. So we need to multiply the numerator times 50. So 1/2 would be the equivalent of 50 over 100. So I want you to take a few minutes, pause the video, and I want you to do the remaining 4 problems and come up with the equivalent, the next equivalent base 10 number up. So start at 10, work to 100, work to 1,000, and keep working until you find one. All right, so pause and we'll come on back. All right, go ahead and do that right now. All right, now that we're back, all right, we did 1/4, right? Can 1/4 go evenly into 10? No, it doesn't, right? 2.5. So, but 1/4 goes evenly into 100, right? How much does it go into 100? That's right, 25 times. Which means if we do the bottom at 25 times, we got to do the top at 25 times. So 1 times 25 is 25 over 100. Okay? So if you got 25 over 100, good job. Now go to 2/5. Can 5 go into 10? It sure can, so we're going to put 10 down here because we go from 5 to 10 by multiplying by 2. So up here, we're going to multiply by 2, and 2 times 2 is 4. So our equivalent fraction of 2/5 is 4/10. Now, if you tried 8, you had to do a little bit of work, right? 8 doesn't go to 10 evenly. 8 didn't even go into 100 evenly. 8 went into, that's right, 1,000 evenly. And it goes into 1,000 125 times. So you got to multiply the top by 125, which gives you 125 over 1,000 is the equivalent fraction scaled up. Okay. And last but not least, 3/4. Well, we know from before already that 4 goes into 100. That's 25 times. So 3 times 25 is 75. And if we come up with its decimal equivalent, okay, well, 25 over 100 is 0.25, right? 4/10 is 0.4. 0.125 is the 125 over 1,000, and 0.75 is the last one. So it says here, what do you notice? If you look, the denominators here, 100, and this terminates in the 100 spot. 100 terminates in the 100 spot. 10 terminates in the 10th spot. 1,000, the 5 terminates in the thousandths spot. And the 100, it terminates in the hundredths spot. So by knowing what number that denominator can go into, it kind of tells you what decimal value your fraction will terminate at as a decimal. All right, so what happens if you try to scale up a fraction with a denominator of 7 or 15? Well, that's a great question. I'm glad you asked. So if I try to scale up to 100, can 7 go into 100 evenly? All right. So if you take 7 on your calculator and divide it into 100, all right, does it go in evenly? 7 divided by 100 is 0.07, right? That's not a nice whole number, is it? That's a fraction. All right. If I did it the other way, 100 divided by 7, it's still 14.28. So there's no number times 7 that can give us 100, right? So no, 7 does not go into 100. Doesn't happen. Well, let's try 15 into 1,000. So if I type 1,000 here and divide it by 15, right, that's 66.6 repeating. So again, that does not go in evenly. So 15, this is another no, 15 does not go into 1,000. So those two numbers with those two denominators did not work like the other ones did, didn't they? And why is that? So again, what types of fractions will result in terminating decimals? When the denominator can go into or be multiplied to get to a power of 10. So when that denominator is a power of 10. The power of, there we go. I get it eventually. And again, what types of fractions are repeating decimals? That's when the denominator is not a power of 10. Two big distinct differences. When it doesn't go into those base 10 numbers, okay, 10, 100, 1,000, so on, it'll repeat. When it goes in, it terminates. All right? So on the back page, we're almost there. Our last focus, okay? Make sure we're recording here. Everything's going smooth. All right? All is good with the world. All right? So now it says, how can you convert decimals into fractions? All right? So we go to the back page here. What are some easy decimals that you know the fraction equivalent? Well, we kind of talked about some earlier, right? 0.5 is what? A half. Good. 0.3 repeating is a third. Good. How about 0.25? What's that fraction? Good. A fourth. 0.75 is 3/4. What about 0.9? What is that? 9/10. Good. Those of you got that? We did 0.2. That's 2/10. I'm sorry, 1/5. 1/5. That was in that earlier table, right? 1/5. Let's do one more. 0.6 repeating is 2/3. All right, those are some basic ones. I'm sure you know a few others. So it says write each fraction as a decimal. Do not round. And then let's describe any patterns that you notice. So what we're going to do here is this table here on the right-hand side. You're going to use your calculator and find those decimals of all the decimals on the left side that end in 9 as a denominator, and then the ones on the right-hand side that end in 11 as a denominator. You're going to go through and fill those decimals in, okay? And then see if you notice any patterns. So we're going to pause the video right now, and I want you guys to work on that. So hit pause. All right, so let's do the 9th column first. So if you did 1 divided by 9, that's 0.1 repeating, right? And if we did 2/9, it's 0.2 repeating. And then we get 0.3 repeating, 0.4 repeating, 0.5 repeating, 0.6 repeating. Remember, it says do not round. Follow the directions. And then the last one is 0.7 repeating. So again, looking for a pattern. If we do the 1/11th side and moving down, you get 0.09 with the 0.9 repeats, 0.18. Well, the 18 repeats every 2 digits. 0.27. 0.36. 0.45. 0.54. And 0.63. So, what patterns do you notice? Well, the denominator of 9, what do you notice about the denominator of 9? Obviously, the denominator of 9 is a repeating decimal, right? It's a repeating decimal. And what else do you notice? Its tenth values, even though they're repeating, are in the tenth value is increasing by 1 every time, right? So the tenths goes up by 1 every time, right? As we add 1 to the numerator, right? 1, 2, 3. Or you could say it actually matches the numerator. So the tenth position matches the numerator. So that's true too, right? All right. So that's one thing with the 9. If you do the 11, right? First of all, it repeats every 2 decimal places, so it's still repeating. But instead of every 10th, like this one does, this one repeats every 2 decimal places. 18, 18, 18, 18, 09, 09, 09, and so on. So it's still repeating. All right, but how does that go up? Well, it increases, if you look at it, it increases by 0.09 every time, right? If you go ahead and add 0.09 to 0.9, you get 0.18. Add 0.9 to this, you get 0.17, and so on and so forth. So it's going up constantly by the same thing, right? So those are some of the patterns that you can see there. All right. We are almost done. So a long time ago, you learned about the power of mixed numbers. Mixed numbers are a beautiful thing, right? So if you look at part L, we have some improper fractions, right? Remember the good old improper fraction? When the numerator is bigger than the denominator? So when the numerator is bigger than the denominator, all right, we have to figure out, okay, how many times can the denominator go into the numerator? Well, 9 can go into 12 one time. So that leaves you the whole number of the mixed number, right? Because in a mixed number, you got a number followed by a numerator and denominator, right? That's a mixed number. So if 9 goes into 12 one time, what's left over? That number that's left over is in the numerator, which would be a 3. And then we leave the denominator with the same, ninths. All right? So we're going to take a second. I'm going to pause the video here for you. You probably won't even notice it. Okay. So, well, I got a negative out in front, right? So number 2, since I got a negative out in front, my mixed number is going to be negative. So 9 can go into 10 how many times? That's 1 time. So again, 9 can go into 10 one time. What does that leave me? What does that leave me? Well, 9 goes into 10 one time, leaving you 1. And we keep the denominator the same at 9. So that gives you 1/9. So negative 1 and 1/9, all right? And we'll come back and we'll give you your decimal equivalent here in just a second. So 10 divided by 11, okay, if you plug that into your calculator, it's not an improper fraction, is it? No. So if I take 10 and divide it by 11, I get 0.90 repeating. That was pretty easy, right? And if number 4 is an improper fraction, numerator bigger than denominator. So how many times can 11 go into 12? 1 time. 1 is left over with the denominator stays at 11. So if I go ahead and do these fractions, I want to take 3/9 because as a decimal, as the 1, the whole number, that's in the 1's position. And then 3/9 is just 0.3 repeating. So 1 and 3/9 is this decimal, 1.3 repeating. If I do negative 1/9, well, again, if you look at the 1/9 up in the table there, it's 0.1 repeating, right? So negative 1 is my 1's value for the decimal. And then for the first place to the right of the decimal, my tenth is the 1 repeating. So negative 1.1 repeating is my decimal. I already got my answer here. And then the other one is negative 1. And 1 divided by 11 is 0.9 repeating. So that is my decimal for that fraction, that mixed number. All right, so on the very bottom here, what I want you to do is the last thing that we're going to do. So it says convert the following decimals to simplified fractions. So you got to play the easier said than done. The simplification game. Simplification game. Wow. So 0.625. If you look at the 5, this is rounded. This is what decimal position. If you actually look at the place value chart in my room. All right, that's 1,000. So this is 625 over 1,000. So now what you have to figure out is how can I simplify that all the way down? All right. So if you take a few minutes to think about it, all right, see what you can get that fraction down to in its simplest form. Because again, simplified fractions mean it cannot go any lower. All right. And if you were to mess around with it, the fraction that it simplifies to is 5/8. I can divide both these by 125 and reduce it. And 5/8 won't go any further because 5 is a prime number. So here's what I want you to do. I want you to write the remaining decimals as fractions. Work with your team. You're going to do 6, 7, 8, 9, 10, 11, 12. We're going to pause the video, and then we'll come up with the final answers when you are finished. So go ahead and pause the video, and we'll see how you finish it up. Okay, so when we finish up here, we got 1.2, right? Well, 1.2 means we have an improper fraction. Okay, we have 2 tenths repeating 1.2. So if this is a tenths, right? This decimal value is in the tenths. That means we have 12 of them. And 12 over 10 is, if you think about it, can reduce, right? I can reduce by 2, right? And if I reduce both sides by 2, I get 6/5. And then 6/5, if you want to simplify the fraction, because you never leave it as an improper fraction, we can reduce it to a mixed number. So 5 goes into 6 one time, leaving me 1. So 1 1/5 can be your simplified fraction for 1.2 repeating. All right. Oh, holy smokes, did I make a mistake on that? You need to erase it. All right, so, wow, I caught that. All right, so erase that. Forget I even spoke. So 0.2, if I look at my table up above, right? 0.2, the fraction part of 0.2 is 2/9, right? And I got a 1 in front of it. So this becomes 1 and 2/9. And since this is a mixed number, I could convert it to an improper fraction if you wanted to, depending on the directions. An improper mixed number to an improper fraction is kind of a whole different story. But you take the denominator, multiply it by the whole number. So 9 times 1 is 9. And then you take the whole number, the answer, and add it to the numerator, which is 2. So your answer could here be 11/9. So depending on how I asked you to finish it, you could have 1 2/9 or 11/9 as your simplified fraction. All right, number 7, 13, prime number, right? The 13 is in the hundredth spot, so that's the hundredths. And that means that it's 13 hundredths. And 13 can't go into 100 because 13 is prime. So there is my answer. Now if I look at 0.7 repeating, look up in the table, where was 0.7 repeating? Right, that's 7/9. Right, 7/9 is 0.7 repeating. It was on the bottom of that table there on the left-hand side where the denominators were 9. And there's a 2 in front of it, right? So that means my decimal, or my fraction, is 2 7/9. And again, if I want to make it an improper fraction, the mixed number, I take 9 and times it by the whole number. So 9 times 2 is 18. And I take that 18 and add 7 to it. And 18 plus 7 is 25. So it could be 2 7/9 or 25/9. All right. 0.81, if you think about it, we get to 9/11 here. It's going up by 2s every time. All right. So it's 0.81 repeating. Well, if you look there, right, 7/11 was 0.63 repeating, right? 8/11 is 0.72 repeating because we had 0.09 to it. And 9/11 is 0.81 repeating. So actually, our correct answer is 9/11 or 0.81 repeating. So you could just extended that table to continue the pattern. 0.74, this would be an easy one to reduce because, again, the 4 is in the hundredths spot. So that's 74 over 100. All right, because it's an even number, you can always reduce by 2. So 2 goes into 74 37 times, and 2 goes into 100 50 times. And 37 happens to be a prime number. That's as low as it could go. All right, 0.6 repeating is 6/9. All right, and that's 1. So 1 6/9 is our number, right? Well, we know that 6/9 can reduce to 2/3, right? Divide each of these by 3. Okay. So 1 2/3 we can reduce, all right, to a improper fraction. 1 times 3 is 3. Add 2 to it, and we get 5/3 as an improper fraction or mixed number, and whatever we're telling you to simplify it to. And then the last one, 0.95. This is a terminating decimal. It terminates at the thousandth spot. So numerator is 95. It's over 1,000. All right. You'll see what can go into it here. Well, they both, one ends in a 5, one's in a 0. So if I divide 95 by 5, that's 19. And I know 1,000 divides by 5 because that's 200. And 19 is a prime number, which means that the only factors are 1 and 19. So if 19 doesn't go into 200, so 200 divided by 19 is 10.52. So this is about as simplified as I can go. There's no factors of 19 that can go into 200. Thus, our simplified fraction is 19/200ths of that decimal. So that concludes our lesson with converting fractions to decimals, irrational rational numbers, terminating and repeating decimals. All right, lots of information to kind of store here. So you should take some time to kind of take this all in. All right, so the homework assignment for this is on page 71, 3 to 12, 73, 32 to 35, and page 75, number 38. So hope you're able to do well with part 2 of the lesson. And again, hope these videos are helping you.